All right, so we're going to be talking about hierarchy of quadrilaterals and their diagonals. All right, so let's just start talking about a quadrilateral. What's a quadrilateral? If a polygon is a quadrilateral, so just so we're sure, polygons, these are closed shapes, sides are straight. And I'll talk more about that in the examples and non-examples. Then it has 4 sides. All right, and then since I'm just super excited, we'll start talking about examples. Like really, if you just make any shape with 4 sides. Okay, it could look like that. Sometimes it can look goofy, like something like this. This is still a closed shape. All the lines are straight, and there's 4 sides. Some of them are very recognizable, like a rectangle. A non-example would be something with a curved side. All right, you could still technically say that has 4 sides, but no. Or, you know, might still have quote-unquote 4 sides, but it's not closed. All right, or maybe even a triangle. That's not a quadrilateral. That's a triangle. All right. Interior angles add to 360, and then I'll just draw a random quadrilateral, something not too crazy but pretty random still. All right, diagonals. All right, this is something we're going to talk about with quadrilaterals, and they can actually be pretty important. Diagonals connect opposite angles. All right, and there we have quadrilateral. It's just a shape with 4 sides. Some examples, non-examples. Interior angles add up to 360. If I erase one of the diagonals, we can tell you why. The angles in this triangle add up to 180. The angles in this triangle add up to 180. You add them together, that's how we get the 360. And I'll add the diagonal back for fun. All right? Now let's start talking about trapezoids, and trapezoids are the ugliest quadrilateral of them all. If a quadrilateral is a trapezoid, then it has at least one pair of parallel sides. All right, and then I just like to start getting after it with the examples. Boom, boom. This is, we'll draw the most famous one, or at least try to draw the most famous one. This would be the isosceles trapezoid. The legs don't have to be congruent, but in this case, they were parallel. Parallel. Some other examples might be something like this. You can throw some right angles in there. Okay, let me make sure I emphasize the parallel part good. There we go. Parallel. So yeah, that could be a right angle if you want. All right, you just need a pair of parallel sides. All right, and they could be ugly, like this right here would even be a trapezoid, a very goofy trapezoid, but it has a pair of parallel sides. All right. Then some non-examples. I don't think we have to go too crazy on the non-examples, but it looks just something like this. All right. No sides parallel. And I got too crazy over here just to emphasize. Yeah, there's different kinds. This is an isosceles trapezoid. This is a right trapezoid. But really, trapezoids, it doesn't matter if that's isosceles or right. It's just the fact that it has an opposite sides are parallel. Characteristics. So this right here, there's some diagonals. All right, here I'm gonna pause a moment so you can write that down. All right, and then there can be like, so overall, for trapezoids, just since they're so crazy, the diagonals really don't do much. They're not guaranteed to do anything in particular. For maybe an isosceles trapezoid, yeah, we could say if isosceles, then diagonals are congruent. So that would be one way to check to see if it was. Put that up there. And then the last thing I guess I want to say is the median. All right. That's the midpoint of that side. That's the midpoint of that side. Okay, I didn't draw that perfect. Let me draw it perfect. It's going to equal base plus base divided by 2. All right, this will be important as we find the area of a trapezoid, where if this is base 1, base 2, we can find the medians of those. All right, there's a bunch more that we could talk about, especially with isosceles trapezoids. I guess very freestyling these notes right now, but if we wanted to name these angles as well, 1, 2, 3, 4, we can say consecutive interior angles are supplementary. Alright, and now I'll probably stop here. As much as I don't like trapezoids, I could ramble about trapezoids for a very long time. Since these lines are parallel, this is a transversal, 1 and 2 are supplementary. 3 and 4 are also supplementary. Alright, so yeah, they have medians, diagonals, consecutive interior angles are supplementary. Yeah, great stuff. Alright, now let's move on to the kite. Alright, this is a kite right here. Then it has 2 pairs of consecutive or adjacent congruent sides. All right, what do I mean by that? I always like just to start drawing the examples. There's actually 2 kinds. It doesn't matter these vocabulary words, but you can have convex or concave. Alright, and did I do a perfect job of drawing these? I'm not sure. Like, adjacent sides are congruent. There's 2 pairs of those. Alright. And then this will be a little bit of foreshadowing, but technically, and I won't go too berserk, because you can go very berserk and get very logic-based talking about this stuff, which I actually like. Technically, all the sides could be congruent, technically. All right. Some non-examples would be, I mean, here's a good non-example. If you drew a shape like this, and we'll actually talk about this specific shape later. Adjacent sides aren't congruent. Yeah, there's two pairs of congruent sides, but we can say congruent sides not adjacent. All right, we'll just keep it simple for that. Now with a kite, I guess we can go, this is where we can go crazy. And this is true of whether it's concave or convex. All right. Okay, if I drew this perfectly, all right, the diagonals, one perpendicular bisects the other. All right. So this is actually very powerful, because now if you look at this kite, you have 4 right triangles, so you can actually figure out a lot of stuff. All right. These purple angles, we'll call this, we'll keep it simple, we'll call this whole thing A, B, C, D. Angle A is congruent to angle C, and they're called non-vertex angles. Angle B is congruent to angle D, and those are the vertex angles. Okay, so the non-vertex angles come from the sides that are non-congruent. The vertex angles come from the sides that are congruent. And just to emphasize, I already used that color. Let's go. That side's congruent to that side. That side's congruent to that side. All right. And yeah, there's probably a billion other things I could talk about kites, but we'll keep it pretty simple. All right. So for the diagonals of that, one perpendicular bisects the other.